Okay, what happens when you have rational exponents? So, here we go. First of all, let's look at exponents that are just integers. So 4 squared versus 4 to the negative 2. If you've got 4 squared, what's really happening is this. It is 4 squared equals 1 times 4 times 4. Which is going to end you up at 16. I always start with 1. 4 to the negative 2. 4 to the negative 2 is equal to 1 divided by 4 divided by 4. So when your exponent is positive, it's just repeated multiplication over and over. Times, 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 times. When your exponent is negative, it's repeated division. So here's why you always got to start with 1. 1, 1, 1, 1, 1, 1, 1. So if we look at the function y equals 2 to the x. So probably the most famous exponential function, y equals 2 to the x. If we plug in 1, 2, 3, so 1 in for x, that is 2 to the 1. 2 in for x, that is 2 squared. 3 in for x, that's 2 cubed. So 2 to the 1 is 1 times just 1, 2. 2 squared is 1 times, you gotta do it twice, 2 times 2. 2 cubed is 1 times, now you gotta do it 3 times, 2 times 2 times 2. So this guy right here gives us results in a 2 for y, this results in 4 for y, this results in 8 for y, 4 is going to result in 16, so on and so forth. Now if you go backwards, 0, this is the beginning, this is what you begin with. So to go forward, I double it, double it, double it, double it. Now to go backwards, I cut it in half. 4 divided 2 is 2, divided 2 is 1. Count any exponential function if it's tripling. So let's look at 3 to the x. Y equals 3 to the x. That's going to be 1 will give you 3, 2 will give you 9, 3 will give you 27, 4 will give you 81. Now if you go backwards, divide 3, divide 3, divide 3, 3 divided 3 is 1. 0 will give you 1. So 0 is the beginning, that's what you start out with. You start out with always a 1. Start out with a 1. Start out with a 1. Okay, now if we go backwards, so if we go backwards here to a negative 1, then it is 1 divide 3. If we do a negative 2, it's 1 divide 3 divide 3. If we do it negative 3, start out with 1, start with 1, divide 3, divide 3, divide 3. So negative exponents are repeated division. Positive exponents are repeated multiplication. And if your exponent is 0, 2 to the 0 is 1, 3 to the 0 is 1, 1 is important. That's what you start out with. That's the beginning. Okay, now let's look at these functions. We've got a linear, y equals 4 times x, and an exponential, y equals 4 to the x. Geometric versus arithmetic. Okay, linear functions can be described as arithmetic, and exponential functions can be described as geometric. Okay, arithmetic, that means they grow by addition, or I guess they shrink by subtraction. Geometric, grow by multiplication, or they shrink by division. So an arithmetic sequence, 1 times 4 gives you 4, 2 times 4 gives you 8, 3 times 4 gives you 12, 4 times 4 gives you 16. So here is the question. What if we go in between? So between 1 and 2, what if we look at 1.5? Or what if we look at 2.5 or 3.5? So these numbers in between the integers, these rational numbers, these decimals. Okay, let's see if we can figure it out. So 4 to 8, that went up 4. 8 to 12, that went up 4. 12 to 16, that went up 4. So now, if I want to go in between 1 and 2, if I want to look at 1.5, 1.5 will result in 6. It will result in 6 because from 4 to 8, I've got a plus 4. So if I split it up into 2 chunks, that's going to be plus 2 and plus 2. Because plus 2 is really the same as one step of plus 4. So let's look at 2.5. 2.5 will result in 10 because if I'm going in between, add 4, I'm going to add 2. Add 2. Okay, let's look at a geometric. So this one grows by multiplication. So from 4 to 16, that was times 4. From 16 to 64, that was times 4. So what if I want to go in between? What if I want 1/2? Or no, I guess it's 1 and 1/2. 1.5. There we go. 1.5. This would be 2.5. So now if we're plugging it in here, this is what I'm asking, is like 4 to the 3/2, which is way better to 4 to the 1 and 1/2. We don't deal much anymore in mixed numbers. We want all your fractions to be improper. So what's going on when you plug in a fraction for an exponent? Here's what you know so far. If you plug in a negative for an exponent, that's division. If you plug in a positive, that's repeated multiplication. But what is going on when you plug in a rational number? So here we go. 1.5. Let me erase this. 1.5 will give you 8. So now if I'm going to go in between times 4, it's going to be times 2. Times 2, because times by 2 and times by 2 is really the same thing as timesing by 4. So if I want to take this and split it up into 2 halves, it's times 2 times 2. 2.5 will give you 32. So I'm going to break that up. That's times 2 times 2. So if I want to go in between times 4, it's times 2. In between plus 4 is plus 2. Okay, now let's look at some hard ones. Okay, you got an arithmetic sequence, a geometric sequence. 1 gives you 2, 2 gives you 4. So arithmetic, that means it grows by addition. So 2 to 4, that went up twice. 4 to 6, that went up twice. 6 to 8, that went up twice. Okay, now, if I want the in-betweeners, if I want 1.5, it will be 3. Because that's going to be plus 1. Plus 1. If I want to go 2.5, that will result in a 5, because in between plus 2 is plus 1. Okay, now this one's not as easy. So this is 2 to 4, that's times by 2. 4 to 8, that's times by 2. 8 to 16 times by 2. So geometric, it grows by multiplication. So this really is the function y equals 2 to the x. Okay, so let's see, where was I? Now if we want to go in between here, it's not as easy. Going in between times 4 is easy, because times 2 is the same thing as times 4. So now, here's what we got to figure out. If you're going to go in between times 2, times what? Times what is the same as times 2? And it is 1.5. 2. I guess I should go back. This is 8 because 4 times 2 is 8. This is 32 because I take the previous one. 16 times 2 is 32. Now I'm going to take the previous 2 and I'm going to multiply it by square root of 2. So if I go in between times 2, it is actually times by square root of 2. Times by square root of 2. Because if I times square root of 2 times square root of 2 is really square root of 4, which is 2. That is the same as timesing by 2. Timesing by 2. So if I do take the previous 2 square roots of 2 and I times it, I want to go in between, I times it by square root of 2, that is 2 square roots of 4. That's 2 times 2, that's 4. That's how we're getting 4. So if I want to go in between 2 and 3, if I want to go 2.5, I am going to take the previous 4 and I'm going to times it by square root of 2. And then if I want to go to 8, I'm going to take 4 square roots of 2, times it by square root of 2. So this, here we go. If I plug in 1.5, 2 to the x, if I plug in 2 to the 3 halves, that one's a little tricky. Let's go back. Should go back to 0.5. 2 to the 3 halves will result in 2 square roots of 2. If I go back 2 to the 1 half, if I go between 0 and 1, so let me come back here to 0.5. So if we start here as 0, 0 is always going to start off at 1. And if I go to the half, I'm going to times it by square root of 2. So 2 to the 1 half is just square root of 2. Now this is a big idea right here. 2 to the 1 half is a square root of 2. This is huge. So if you have exponents that are fractions, these rational numbers, they're timesing by radicals. And if it was subtract, it would be dividing by radicals. So when your exponents are rational, there are radicals going on because it's what's in between times 2. And in between times 2, if you take half of times 2, it's times the square root of 2 times square root of 2. So it's kind of tricky, but maybe will make better sense with this. Okay, if we've got x to the 7th, square root, so that is, there are several squares. If there's no number, it is invisible to square root. So this will undo any squares. And you should have a square, a square, a square, and one left over. So in 7, we got a square, a square, a square. So 2, 4, 6, there are my 7 x's. Anytime there is a square, now if you want to write them out the long way, that's a pair, that's a pair, that's a pair. A pair is a square. So this square root is going to kill that square. So this x comes out, kills that square. This x comes out, kills that square. This x comes out. So square root of x to the 7 is 3 squares made it out, and there is 1 left over. And you could also write this as x cubed times x to the 1/2. Because you got a half of a square in here. There's only 1 left, and that is half of a square. So this is the same as this. Okay, let's do a harder one. So the index is 3, that means it's a cube root. So they come out in pairs of 3. So if you got 5 x's, x, 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 that's a cube. You've got 1 cube and you've got 2 left over. Okay, this cube root is going to kill a cube. So you're going to have 1x on the outside and then a cube root. You've got 2 left inside. So now this is the same thing as you had 1 cube make it out, and you have 2/3 remaining underneath. So 2/3 of a cube left under. So this is the same as this. Okay, let's do one more. If you got the 7th root of x to the 9th, that means they come out in 7s. So you gotta have 7 of them. And if you got 9, that means you got 7 and you got 2 left over. So this 7th root will undo this 7th power. So you got 1 group that comes out. And don't forget to put the 7, because if you don't put a number, it's 2. You got x squared in there. So that means 1 made it out, and you have 2/7 of 1 that did not make it out. Okay. So if you have x to the 1/2, that means you have x, 1, 2. If you got x to the 2/3, that means you have x, 2, 3. That means it's a cube root. This means it's a square root. If you got x, this is a good one, x to the 7/4, that means you got x to the 7. 4 is the index. They are coming out in groups of 4. And if you got 7, there's some that can come out, because that is going to be, there's 4, so we got x, 4, x, 3, that's 7 of them. So this 4th root is going to undo this 4th power, so x comes out, and you got 4th root, you have x, 3 in. Now check this out. Hopefully you can recall that 7/4 is the same thing as 1 3/4 back in your middle school days. So this guy right here, if I take x times the 4th root of x cubed, that is going to be the same thing. 1/4 made it out, 1 group of 4 made it out, and then I have 3/4 of another. So I've got 1 3/4, 1 3/4. Pretty freaking awesome. So here's the big idea. The grand model is this. Okay, now we are going to morph. Morphing is awesome. We're going to morph back and forth. So if I give you x to the a over b, this is exponential. This is how it looks in exponential form. Now if you morph it, that will turn into radical form. So if I morph x to the a over b into radical form, that is going to be x goes there, so you gotta know which piece goes where. A goes there, and b will be your index. B will tell you what you're taking them out by. Okay, so that's how you morph back and forth. Here we go. you've got to evaluate these. 81 to the 1/4, it is in exponential. Let's morph it. So let's go radical. Let's put 81 here. 81 1/4. Okay, there we go. Now 81 busted up. Let's see if there's any fours, groups of 4 in there. 81 is 9 times 9. 9 is 3 times 3. 9 is 3 times 3. So that is really the 4th root of 3 to the 4th. And since I've got a 4th root and a 4th power, they will undo each other, and your answer is 3. That is awesome. Okay, let's do 4 to the 1/2. 4 to the 1/2. Morph it. If you morph them, it's going to make it easier. 4 to the 1/2. That would be a square root of 4, and you just have one of them. And the square root of 4 is pretty common. That's just 2. 243 to the 4/5. Okay, this one is going to be the hardest one so far. 243 to the 4/5. Let's try this. Okay, it's going to look like this. 243 goes here. I've got 4 of them, and I am 5th rooting, so things come out in powers of 5. Okay, 243, let me bust that up. 243 divided by, what does it divide by? 243 divided by, okay, it divides by 9. So let's go 9 and 27. 9 is 3 and 3. Done and done. 27 is 9 and 3. That's done. 9 is 3 and 3. There we go. So here is what we've got. Let me change this out. I've got the 5th root of 1, 2, 3, 4. I've got 5. 243 is 3 to the 5th, but I have 4 of them. I got 4 of them. So that is the same thing as the 5th root of 3 to the 5th 4 times. I'm going to times the 4 and 5. That's the same thing as 3 to the 20th. That means I'm going to have 20 of these 3's. And they come out in powers of 5. So if I've got 20, that works out perfect. Because I've got 3 to the 5, 3 to the 10, 3 to the 15, 3 to the, whoops. If I rewrite them in powers of 5, 4 of them will come out. And 3 to the 4th is something. 3 to the 4th is 81. Awesome. Next. Okay, what if you have to simplify this expression? M to the 2/9 times M to the 16/9? Okay, you're multiplying. So do not ever change the base, but you add the exponents. So 2/9 plus 16/9, that equals M to the 18/9, which is M squared. Now it's a positive integer, so that's just repeated multiplication. So that'd be like M times M, or 1 times M times M. I always start with 1. Okay, the next one, P to the 1/5 times P to the 1/2. This is not as easy. It is going to be P to the 1/5 add 1/2. Then these are not like terms. Fifths and halves are not like terms. So I need to change them both so that they are measuring by tenths. So I've got to times this by 2 over 2. So it's going to be P to the 2/10 plus, I've got to times this one by 5 and times this one by 5, plus P to the, I guess we're going to do times, P to the 5/10. And now it's going to be P to the 2/10 plus 5/10. That is going to equal P to the 7/10. And if you morph it so that it looks in radical form, radical P, you're going to have 7 of them, and they come out in powers of 10. And since I only have 7, they're going to stay in. They're not going to come out. Okay. let's try the next ones. 49, you can change that to, here's what we got. 8th root of 7 squared, a to the 8th, b squared. Okay, this 8th root is going to undo this 8th power, so a comes out. So I've got a 7 squared b squared, and you're done. Okay, if you want to morph it, I gotta put an 8 there so I know it's an 8th root. If you morph it, it's gonna be a, when I'm came out, I'm gonna have, what's up, 7 to the 2 8s, b to the 2 8s. I haven't seen it. And then clean these up, 2 8s and 2 8s. Go one more step. So go a to the 1, 7 to the 1 4th, b to the 1 4th. And for fun, if you wanted to morph it back, you could go a to the outside, and now you've got 4th root of 7 and b, because 2 8s is the exact same as 1 4th. So all three of these are the same. Okay, the next one, 64. Let's break it down. So if you have a number, always break it down. 64 is 8 and 8. And that is 2 times 2 times 2. And that is 2 times 2 times 2. So we're going to go the 12th root of 2 to the 6th. If you morph it, it's going to be 2 to the 6 twelfths. If you simplify it, it's 2 to the 1 half. If you morph it, it is 2 1 square root of 2. That is the same thing as square root of 2. And we never really write the 1 or the index of 2. Okay, last one. Square root of x. I guess the square root of the square root of x. Okay, morph this. If you have the square root of x, that's a 1, that's a 2, that will morph to x to the 1 half. So let's plug that in there. So we're going to go square root of x to the 1 half. If you morph that, it's going to be x to the 1 half and divided by 2, which is x to the 1 4th, which is the same thing as 4th root of x. So that's the same, that's the same. Either one of these.